Hello everyone and welcome back. My name is Mr. Cobalt, and in this video I'm going to be going over how to solve a problem where you have a mixture of two metals that react to form a certain amount of hydrogen, and you're asked to find the percent aluminum by mass of this alloy ferroaluminum. And so let's get into this. So in this particular problem, we're given a 2.50 gram sample of an iron aluminum alloy called ferroaluminum, and it's dissolved in an excess amount of HCl to produce 0.105 grams of H2 gas. They want to know what the percent aluminum by mass of the ferroaluminum. So let's get into this. So when you're doing this sort of problem, you're going to need to do a system of equations, and you're going to need two equations. So let me show you how you do this. So the first piece of information they give us is that we have a 2.50 sample of the ferroaluminum. So that means that the 2.50 grams is made up of both aluminum and iron together, right? And we want to know what the percent of the aluminum is. So we need to know how much of each one, but we don't know how much of each one, but we do know that the two together is added up to 2.50 grams. So we can write that as our first equation. But first, we need to identify, well, we could write it like this. We could say aluminum plus, or here, let's do it this way. We'll call aluminum X, right? Aluminum is X, and we'll say that iron is Y. So then if we know that both of these together is equal to 2.50 grams, then our equation would be X plus Y is equal to 2.50 grams. Okay, so that is our one equation, right? But we need another equation because look, we have two unknowns. In order to solve a problem that has two unknowns, you need two equations. So where's our other equation going to come from? Well, that's going to be related to our other piece of information we're given. We're told that the iron aluminum, the ferroaluminum, reacts with enough HCl to produce 0.105 grams total of your hydrogen gas. Well, what does that mean? It means that the iron and the aluminum together produced this amount of gas. So the amount of aluminum that we have in our substance produced a certain amount of hydrogen gas, and the iron in the alloy also produced a certain amount of hydrogen gas. The two amounts of hydrogen gas added together is equal to that amount there. So what we need to do is calculate the amount of hydrogen that came from each part of the alloy. Calculate the amount that came from iron and calculate the amount that came from the aluminum. Well, how are we going to do that? Well, since we said that aluminum is X and iron is Y, we can use X and Y to convert the grams of the aluminum and iron into grams of the hydrogen gas using stoichiometry. But this time, since we don't know the amounts of X and Y, we're just going to use X and Y in our conversions. So let's go ahead and start with iron. That's our first equation. We'll start with iron. Iron is Y. So if I write out the equation, I'm just going to do stoichiometry. That's the only thing I'm going to be doing. So the steps in stoichiometry are going to be the same, except instead of starting with some number of a substance, I'm going to start with a variable, or not a variable, but an X amount of that substance, right? So here we have Y. So I have a Y amount of iron, or let's say I have Y grams of iron. Okay? And I'm going to start that with over 1. And now my goal is to convert that to grams of hydrogen gas produced from Y grams of iron. So I'm going to do stoichiometry. The first thing I need to do is convert grams to moles using molar mass. So I'm going to use the molar mass of iron. And so iron, if I look it up really quick, is going to be 55,845. So 55.845 grams of iron is equal to 1 mole of iron. So grams of iron cancel out. Now I have moles of iron. And so now I can do a mole ratio between iron and hydrogen gas. And you'll see here that it's a 1-to-1 molar ratio. So I'm just going to use a 1-to-1 mole ratio. So for every 1 mole of iron, I get 1 mole of H2 gas. Notice I put moles of iron on the bottom to cancel out, so that's going to cancel out. Now I have moles of H2 gas, but I don't want moles, I want grams. So I'm going to have to use the molar mass of hydrogen to convert to grams. So 1 more. So I have 1 mole of H2 on the bottom to cancel out here. And then I have 2.018 grams of H2 on the top. So moles of hydrogen cancel out. And so now I have grams of hydrogen. So now all I need to do is multiply across the top, divide by the bottom, and I'll get my answer. But again, it'll be in terms of Y. So when I calculate this out, it becomes 0.3614. So 3614. Oops, sorry. 0.3614 grams of hydrogen. Okay, so here I have calculated the amount of grams in terms of Y, which is iron. Okay, so now I have the amount of grams, and notice all I did was I multiplied by 1. I didn't really multiply by ones, but I took 2.018 and divided by 5.5845, and I got the 0.03614, and then I got the Y here. Can't forget the Y because that's multiplied by everything as well. So here I have 0.0. Oops. Let me get rid of the hydrogen here. Grams times Y. Oops, wait, sorry. Let me make this better. So 0.03614 times Y grams of hydrogen, right? So this is the amount of grams that came from a Y amount of iron. So now I did the iron, now I can do the aluminum, X, right? So now I'm going to figure out, I start with an X amount of grams of aluminum over 1. And then I'm going to do the exact same thing. I'm going to take grams of aluminum and convert that using stoichiometry, using this bottom equation now, to convert to grams of hydrogen from the aluminum. So I'm going to use the molar mass of aluminum. And so when I look up the molar mass of aluminum, I get 2698. So 26.98 grams of aluminum on the bottom, 1 mole of aluminum on top. So grams cancel out. Now that I have grams, I have moles of aluminum on top. Now I can use the mole ratio between aluminum and hydrogen to convert to moles of hydrogen. So I'm going to use that mole ratio. So 2 moles of aluminum produces 3 moles of hydrogen. So 2 moles of aluminum on the bottom and 3 moles of hydrogen on top. Moles of aluminum cancel out. Now I have moles of hydrogen again. So now I'm going to multiply by the molar ratio, the molar mass of hydrogen to get grams. And so now I'm going to put 1 mole of H2 on the bottom and 2.018 grams of hydrogen on top. Moles of hydrogen cancel out. Now I have grams. So once again, all I'm going to do is multiply by everything across the top, divide by everything on the bottom. I'm skipping the 1. So basically it's going to be x times 3 times 2.018 divided by 26.98 divided by 2. That's going to give my answer. And when I do that, I get 0.1122 grams. 0.1122 times x. We can't forget the times x. So times x grams of H2. So now I have both the gram amount of hydrogen in terms of x from an x amount of aluminum, and I have the gram amount of hydrogen in terms of y from a y amount of iron. So I know that both of these amounts add up to this total here, so I get my second equation. So my second equation is going to be 0.1122 x plus 0.03614 y is equal to 0.105. 0.105. So there's my second equation. So now all I need to do, so I have this equation and I have this equation. So now all I have to do is solve for the missing part. So what do I want to find? They want me to find the percent aluminum. Which one is aluminum? X. So I want my equation in terms of X. So that means I'm going to solve this for Y and substitute it in for this equation. So Y here is going to be equal to 2.50 minus x. So now what I can do is I can substitute this in for y. So then my equation becomes 0.1122 x plus 0.03614 times, instead of y, I'm going to put in this. It's going to be times 2.50 minus x equal to 0.105. So now at this point, it's just algebra. So I'm going to solve this for x, and when I find x, I'll have the number of grams in the total of 2.50. The number of grams of x, which is aluminum. Once I find that, I'm home free to find the mass percent. So let's go ahead and do the algebra here. So I'm going to multiply this through. So I'm going to multiply this by 2.50 and also x. So when I multiply these together, I get 0.09035. So this is going to be 0.1122x plus, what I say is 9035. So it's going to be 0.09035 minus, and then this times x. So it's just going to be 0.03614 x, and that's going to be equal to, again, 0.105. Now that I've got that kind of multiplied out, now I'm going to have to add the like terms together. So here I'm going to have to add the x's together. So this is a negative. So I'm going to subtract this from this. And when I do that, I get 0.07606. Yep, 7606. So then I got 0.07606 x plus 0.0905 is equal to 0.105. And then my next step is to add these two terms together. So I'm going to have to subtract 0.0905 from both sides. So then I do that. So minus 0.0905 minus 0.0905. So these cancel out. And so I'm going to subtract those. And when I subtract those, I get, oh, hold on a second. I don't know why I did that, but it should be a 3-5, not a, you're probably wondering, how in the world do you get 5? So that should be 9035, 9035. Okay, so when I subtract that, I'm going to get 0.01465. Oops. Sorry about that. So I get 0.01465. So now I'm going to make some room up here since I don't need this anymore. All right, so then what I get is 0.07606 times x, and then that's going to be equal to, what did I say? 0.01465. 0.01465. So now all I need to do is divide both sides by this to get x by itself, and I get my answer. So I'm going to divide this by 0.07606, and then I'm going to divide this by 0.07606, and this cancels out, and then, oops, x is going to be equal to 0.1926, 0.1926 grams. So this is the gram amount that of iron in the alloy, the original alloy. So here we have x equals aluminum. So this is equal to the mass of aluminum that was in the original sample of 2.50 grams. We're being asked to calculate the percent aluminum. So just a reminder, a percent is calculated by the part divided by the whole multiplied by 100. So that's why it's percent. Percent means per 100, out of 100. So you get the fraction by multiplying or dividing part divided by whole, and then multiply by 100 to get the percent. Okay, so here we've got a part. This is a part of the whole. So we're going to find the percent by 0.1926 grams of aluminum. That's the part of the hull. Our hull is the alloy that's made up of aluminum and iron. And that was 2.50 grams total. And we're going to multiply that by 100. And when we calculate that out, we get 7.70%. And so that, ladies and gentlemen, is how you find the percentage of a given element or given metal in an alloy for this reaction to produce hydrogen. So that's how you attack these sorts of problems. If you're ever given a mixture of something that reacts to form one product, so they both react to form the same product, then you got to use a system of equations where if they give you the total amount of the sample that's reacted and the total amount of product that's formed, you can form the two equations. One for the total amount of reactant that you were given, one for the total, I erased it. One for the total amount of product that was formed, okay? And so that's how you do that sort of problem. I hope you enjoyed this video. If this helped you in any way, then please, by all means, like the video, share the video, hit that like button somewhere around there. Also, support my channel. Subscribe to the channel, hit that notification bell. When you do, make sure you click all so you can be notified by all the videos I put out. Finally, put a comment down below in the comment section. Let me know what you think. Ask me questions. I would love to hear from you. If you have a question or a problem you need help with, or if you have a topic you want me to cover, I would love to do that for you. Thanks for joining me and have a great day.